Here we want to use the calculator to help us conduct a hypothesis test about a proportion. Here we claim that with the XOR method, the proportion of girls is greater than 0.5. That is, we have an alternative hypothesis that P is greater than 0.5. Our sample data would be a sample size of 726 babies, 668 of which are girls. So consider our test. We have the alternative hypothesis and the null hypothesis stated here. And so to get started on the calculator, we'll press Stat, arrow over to Test, and here we will choose a 1 proportion z-test. So I'll select number 5. So the first thing it's going to ask us for is what is P0? And so the assumption in the null hypothesis is that P would be 0.5. So 0.5 is our P sub 0. X, the number of successes, the number of girls, in this case was 668. The sample size, the number of babies, was 726. We're arguing that the proportion is greater than 0.5. And then we calculate. And so testing the alternative that the proportion is actually greater than 0.5, we get a z statistic, a z-score here of 22.639. That's an incredibly large z statistic. Thus our p value, p is essentially 0. It is so small the calculator rounds it to 0. P hat, the proportion or percent that we witnessed, was 92% girls. So in this case we have overwhelming evidence to support the fact that the true proportion of girls born using this method exceeds 50%, or the proportion is greater than 0.5.